All right, so we're in chapter 3, 3.2. So what we did in the last section is we took a bunch of data and we talked about what the middle of it was, right? 3 different ways, mean, median, and mode. The middle of a bunch of data, the center. Now what we want to do is say, okay, not only does it matter what the middle is, but it matters how spread out or compact the data is, how the data varies. That's actually probably one of the most important, the author claims it's the most important thing, probably, for statistics. They want to know, what people use statistics to know not only what the middle of a bunch of numbers is, but how spread out are the numbers? Are they all clumped right at the middle? Or are they spread out really wide around the middle? You know, what's the spread of the numbers? What's the variation? That's what this section is all about. How do you figure out how spread out numbers is? Super important in statistics. So, there's 3 ways to measure the spread. Range, that's super easy. Standard deviation and variance, which are basically the same thing. All right, so let's talk about them. Range, we'll start with the first one, really easy. Range is just the maximum minus the minimum. That's simple. Just take the biggest one minus the smallest one. That's the range of numbers. Like if I said, hey, after our first exam, you know, since we're a stats class, I should probably give you a whole bunch of stats after the first exam. You know, if I said, all right, here's all the scores, and the high score was 100. Somebody can get 100? 100 was the high score, and the low score was 40. Maybe. I don't know. 40. So I didn't know people got 40s on exams until I was first a teacher. I didn't get any 40s. But, I did get a 40 one time, actually. Yeah, one time I did get a 40. Yeah, anyway. All right, there's always levels, huh? You think you're kind of smart, you go away to the big college, and they all just laugh at you. Anyway, so that's what Dr. Hood. So, anyways, let's suppose on the first exam, somebody gets 100 and somebody gets 40. So what would the range be? It'd be 60, right? It's how far from the lowest to the highest, the range. All right, let's move on. Important properties, it's not very resistant. Yeah. All right, so here we go. Here's an example of the range. This is pretty simple. So you just have to grab the highest number, 55.6, and the lowest number, 14.1, subtract them, 41.5. That's all it is. High minus low. Nothing else going on there. Let's get to the other stuff. Standard deviation. Now this is important. Standard deviation. Really. We'll use standard deviation all semester long. So don't worry about population stuff. We'll do that later. Let's just get to business. This is the easier formula to use. Now, if you have the TI, it's just going to be automatic for you. So you won't have to do that big old ugly formula. So I'll show you. Just put in the numbers and hit the button, and that's that S that came out. That is the standard deviation. It'll do it for you automatically. So if not, you're going to have to use this. This one will be easier. Like this is a shortcut. I mean, I know it doesn't look very pretty, but it is a shortcut. It's easier than that one. I'll show you both ways. So there's the formula we're going to use. Let's go to it. I'll come back to that screen when we need it. All right, properties. What is it? How are we doing on time? So let's just get to one and do it, huh? All right, that's about all we have time for anyway. So let's get to this problem. Here we go. Back to the Verizon data. So the data speeds. We want to know now, not the middle. We did that in the last section. We want to know how spread out are those numbers? How spread out are they? That's what standard deviation means. It means average distance from the middle. And we'll talk about that. I'll say that all semester long. And it'll make more and more sense as we go on. What standard deviation is typical deviate? You know, what's deviation? What's a social deviant? What does that mean? Somebody that acts different than normal people, right? A social deviant is one whose behavior deviates from normal, what we're used to, right? So standard deviation means average distance from the middle. See, it's the same kind of thing. Standard deviation is average distance from the middle. So like in this data set, there is a middle. I don't remember. We found it out an hour ago. Whatever the middle is, how far are these numbers from that middle? That's what we're going to figure out now, called standard deviation. How far are they from the middle on average? Some of them are really far from the middle. Some are close to the middle. How far are they typically from the middle? That's standard deviation. All right, let's do it. Let's crank it out. So if you have the TI 8384 thing, just put it in L1, hit the buttons, and look down for the S. That's it. It is in that list already. So let's do it. So I'll do that first off. All right. So let's do it. So what is this is? Does that look crazy? Does that look like Greek to you? Because it is. I'm joking. That is Greek. That is a Greek symbol. That is a big Greek S is what that is. That's sigma, it's called. That just means sum them up. It's an S for something. It kind of looks sort of like an S. That means add up the x squareds. We're running out of time, so I'll just do this quick. We'll do more of it next time. So that just means what you got to do is you got to list these numbers. You got to do a lot of work here, unfortunately. So you got to list the numbers: 38.5, 55.6, 22.4, 14.1, 23.1, and then you got to square each of them. You know what I mean? You got to square each of them, one at a time. It's painful. So 38.5 squared. I'm getting 1482.25, and then the next one squared. I'm getting 3091.36, and then the next one squared. 501.76. This is the easier one, believe it or not. Square the next one. 198.81. Square the next one. And this is just for 5 numbers. What if they give us like 10 or 20? That's when it really gets bad by hand. All right, and then we add those up. So we add these up and add these up. That's what they mean by the sum of the x squareds and the sum of the x's. I guess here it is right here. This must come out, or actually this comes out 1. This is this one. This is the sum of the x's. This is 153.7. And this one is 5807.79, the x squareds. Is that making sense? And then you plug that into that formula. This formula. And you square root it, and you do all that stuff, and you'll get the same answer.
So that E right there, that stands for...
Add them up. It's an S, really. It's a Greek S. It means sum them up, add them up. This means add up the x squareds. Boom. And this means add up the x's. Boom. That's what that means.
Man, you explained it so well, man. I was like, ah, so I was like, okay, I get it.
Does that make sense? So you don't have to do it with the TI. You can just hit the button. But that's what these mean. It means add up the x's, add up the x squareds.
Okay.
Right? And then, then there's more, and we're running out of time. So we'll do more of that next time.